In this video, we'll talk about the electrocardiogram, ECG or EKG. Just to let you know, those acronyms mean the same thing. It's just that K comes from the German spelling of electrocardiogram. Now, when it comes to the electrocardiogram, we'll talk a little bit about it in lecture, but you'll talk about it more in lab, and you'll actually be able to see and measure an EKG in lab. So we have this one outcome for this video. So here is a typical electrocardiogram. Now, one of the things that's not shown on here that you may or may not see in lab is something called a U wave. And a U wave is another little small wave that comes right after the T wave. It's not always there, and I generally don't talk about it, but at least want to acknowledge that it exists. So when it comes to the EKG, we have waves, we have complexes. A wave is wherever we have electrical activity, okay? And so you can see we've got a couple of waves here. We've got the P wave and we've got the T wave, okay? The P wave is when the atria are depolarizing. And when they're depolarizing, they're getting ready to contract, just like we've talked about with muscle physiology as well as action potentials in a neuron. We've got the QRS complex. Now, a complex is made up of multiple waves. Okay, and we've got the Q, the R, and the S. Okay, and so you can see that here. So we've got the Q is this little downward deflection, R is the big, large one up, and then S is the downward deflection as well. During the QRS complex, this is when the ventricles are depolarizing. So similar to when the atria were depolarizing, the atria were contracting. Well, in this case, the ventricles are contracting or getting ready to contract. Now, at the same time that this is going on, the atria are repolarizing, but we cannot see that electrical activity on an EKG, at least not on a standard one like this. And that's because the electrical activity of the ventricle just dominates here. Just a reminder, an EKG is a measurement of all the electrical activity going on in your heart at any given minute or moment. Okay, and so what happens there is there's just a lot more ventricular muscle, so there's more electrical activity, so it essentially drowns out or prevents us from being able to see the effects of atrial repolarization. Then you've got the T wave, and so the T wave is ventricular repolarization. So this is when contraction's ending and the ventricle is beginning to repolarize or relax. So then we've got segments. Segments are what we call an isoelectric line. What that means is there's nothing that's going on, at least there's no electrical activity. And so you can see that multiple places. We've got one here and we've got one here, and then you've got this big long one as well. So you've got the PR segment. Now there is a PR interval as well that you can see on the bottom of this figure. Now the PR segment, remember, that's just the flat part. This occurs between the end of the P wave and the start of the Q wave, or the start of the QRS complex. Basically what's going on here is a signal has been sent from the SA node to the AV node, but nothing's happening because the AV node holds on to that signal for a short period of time to allow the ventricles to top off. Then you've got the ST segment. So this occurs at the end of the S wave until the beginning of the T wave. And so this really is the full time that the ventricles are depolarized and contracting. As I mentioned, we've got intervals. Okay, so an interval is where we have a wave and a connecting segment. So there are several of these. We're just going to focus on two. So you've got the PR interval. So notice that the PR interval is the same thing as the PR segment, but we've added the P wave. And so you can see that from this figure here. So here's my PR interval. Notice we've got the P wave and we've got the PR segment. Okay, and so this is ultimately the time it takes that electrical signal to travel through the atria and into and through the AV node. Then we've got the QT interval. So it's similar. So this is from the beginning of the QRS complex to the end of the T wave. So in this case, the segment comes first. And so this is ventricular depolarization and repolarization. And so this corresponds, not exactly, but pretty close to ventricular systole. Or in other words, when the ventricle is contracting. So to summarize, you got the P wave, which is atrial depolarization. The QRS complex is where we have ventricular depolarization. Atrial repolarization is also occurring. We just can't see it. The T wave is when ventricular repolarization is occurring. The PR segment is the time that signal is being held by the AV node to allow for ventricular filling or to top off the ventricles. The ST segment just lets us know when those ventricles are depolarized. And then we've got the PR interval, which is when atrial depolarization starts to when ventricular depolarization starts. And the QT interval is essentially the time when ventricular depolarization and repolarization are occurring. I've got a table here. I'm not going through this. You can screenshot this, but it shows you kind of a definition, what's going on with each of these segments, complexes, waves, and intervals. So at the end of this video, can you draw an EKG or ECG and label each wave, segment, and interval? And can you describe what's occurring during each of these waves, segments, and intervals?